And we have a chair there ready for you.
Vicki Scott had a stroke nearly 40 years ago. In the beginning, she couldn't walk or talk. She's come a long way.
Comfortable? All right.
Now she wants to help future stroke survivors have the best shot possible at a good recovery. That's what brings her to the University of Pittsburgh, where she volunteers as a research test subject.
I'm very interested in this human ability to adapt our gait pattern in different situations.
With support from the National Science Foundation, bioengineer Helsi Torres Oviedo and her team are using rehabilitation robotics and motion capture cameras to study locomotor learning. That's the ability of a patient with an impaired gait, like Vicki, to adapt her walking patterns and learn new movements.
Patients with a stroke often have an asymmetric gait, which impairs their mobility and limits the activities that they can do in daily life. So the question is, how can we help the gait rehabilitation of these patients?
The belts on this treadmill move at different speeds, so Vicki has to work her affected right leg harder than her left.
The corrections that they are making are training the neural commands that generate walking movements.
But they found what's learned on the treadmill often doesn't stick.
Okay, perfect.
A common finding is that patients are able to adapt and correct their movements while they're using the device, but as soon as they let go of the device, then their corrections don't carry over as much.
It's a quirk in the way we learn. Walking on a split-belt treadmill is an unusual enough experience that the mind classifies it as a novelty. Test subjects can learn to adjust their movements while they're on it, but once they get off, old gait patterns creep back in.
We're very interested in understanding what are the factors that determine that specificity in the learning, and can we manipulate them? Can we make patients carry over more of the learning that they acquire to their real lives?
They're tweaking their methods to see if they can make that happen, like switching up the speed of the belts and changing the incline. They even have the test subject play a video game of sorts, trying to step on targets.
And we thought, well, perhaps if we give them feedback telling them where to step, maybe they will be able to correct their gait better.
These motorized shoes work on the same principle as a treadmill. They can be programmed to control the speed and length of the steps. These are an early prototype that they're testing with young, healthy people. Eventually, the stability and control algorithms will improve to the point a person with an impaired gait could safely put them on.
We can train them first in the lab under a very safe and constrained environment so that they would get used to using this pair of shoes. And then eventually the idea is for them to wear them, like take them with them home and wear them everywhere they walk.
Yep, there you go. Perfect.
The team's long-term goal is a customized robotic rehabilitation plan for every patient.
It would be wonderful if one could use quantitative tools to characterize in a very systematic manner the impairments that every stroke survivor has, and based on that, tailor the intervention.
Helping stroke patients learn to get back on their feet. For Science Nation, I'm Miles O'Brien.